Okay, I am going to go through and just do some of these homework problems. I'm going to go through them quickly, just extra for you, just to kind of explain. So I have 8x minus 4 is greater than 60. And then I have 8x minus 4. Here's my keep what's in the inside. Change the inequality symbol, change the number. So less than negative 60. Add 8x is greater than 64. Divide by 8. X is greater than 8, add 4, 8x is less than negative 56, divide by 8, x is less than negative 7, because I divided by the positive, I don't have to worry about that. So I look at my answers, I'm going to have an open circle around 8, and it's greater than, so it's going to be to the right. I have an open circle around negative 7, and my arrow is going to the left because it's less than. When I think about interval notation, if I have an arrow to the left, if they don't connect, it's going to be negative infinity. And on the right-hand side of my graph, if they are going right, it's positive infinity. So I know my solutions are going to go from negative infinity to negative 7. And then the other part of my graph goes from 8 to positive infinity. I put my open parentheses around my negative infinity and positive infinity, and I look at my graph, it's not or equal to, so I put that, and there we go. Okay, the next one, I add 8 to each side. I have the absolute value of x plus 2 is greater than or equal to negative 10. And I stop, because as soon as I see that this is a negative, I know that this is going to be something weird. If this was an equation, it'd be no solution. So for this, I can't remember, let's say I can't remember the rules. So I just write the word positive. So if I say a positive number is greater than negative 10. Is that true or false? Well, this is true. It's always true. If this is always true, then my answer here is this is going to be all real numbers. In other words, I could use any number at all and it would work. So I know that for my graph, I'm just going to draw a line above it, goes to the left and to the right. And so my interval notation, since it's all real numbers, well, no matter what value any value I could think of, I could put in for x. So it's from negative infinity to positive infinity. Number 3, first thing I do is I divide by 3. This is the absolute value of 2x plus 5 is less than 11. I solve it twice. 2x plus 5 is less than 11. 2x plus 5, I keep my inside absolute value, change this to greater than, change this to negative 11. I subtract 5. This is going to be 2x is less than 6. Divide by 2. X is less than 3. I subtract 5 from each side. 2x is greater than negative 16. Divide by 2. X is greater than negative 8. And so I graph it. So I put a little circle around 3. It's going to be an open circle still in this case. And I know it's going to be less than 3, so I put a little arrow here. At negative 8, I put an open circle. It's greater than negative 8. Since my arrows are pointing towards each other, I know that they're going to be connected. So when it asks me my interval notation, I'm going to have only one interval because there's one graph, and it's going to go from, my interval goes from negative 8 to positive 3. I keep open parentheses because it is not or equal to. All right, last 3. So first thing I do, I subtract 5. I have negative 4 times the absolute value of 4a plus 4 is less than or equal to negative 112. Next thing I do, I divide by negative 4. Now I remember if I divide by a negative 4, I have 4a plus 4. When I divide by the negative 4, I have to switch my inequality symbol. And so that ends up being 3, or no, not 3, sorry, 28. Sorry, guys. Yeah, positive 28. Okay, I don't have any nonsense over here. I don't have any negatives, so I'm just going to go through and solve it twice. So I have either 4a plus 4 greater than or equal to positive 28, or I have 4a plus 4 is less than or equal to negative 28. Subtract 4, 4a is greater than or equal to 24. Divide by 4, divide by 4, a is greater than or equal to 6. Minus 4, 4a is less than or equal to negative 32. Divide by 4, divide by 4, a is less than or equal to negative 8. And I graph that. So I go to 6. I put an open circle, but I'm going to fill it in around 6. It says a is greater than 6. I go to negative 8. I have an open circle, but then I close it up, and it's less than negative 8, so it's going to go to the left. If I have an arrow to the left, that's negative infinity. An arrow to the right is positive infinity. And so my interval notation, I know that part of my graph goes from negative infinity but stops at negative 8. And I know the other part starts at 6 and keeps going to infinity. For my open parentheses around my infinities, see that that is closed, and it's OR. Okay. Last two, I subtract 4. This is going to be negative 3 times the absolute value of 9x plus 9 is greater than or equal to negative 27. I divide by negative 3. Okay. I end up with the absolute value of 9x plus 9. Now I switch my symbol because I divided by this negative 3 here. So this is going to be less than or equal to, actually, why did I put negative 27? This should be positive 27. Sorry about that. Didn't want to throw you off. Silly mistake. And then this is going to be less than or equal to negative 9. I stop here because as soon as I see I have an absolute value, when I get my absolute value by itself, if I have a negative, that means there's going to be something funky going on. Again, if you don't remember the rules, you just write the word. I write positive number. Can a positive number be less than negative 9? No, that's not possible. You cannot have a positive number less than negative 9. So this is going to be no solutions, and you leave the number line blank because there's no solutions. Last one, add 14 to each side. 2/5, 5x plus 10 is less than or equal to positive 8. I multiply each side by 5. 2 times the absolute value of 5x plus 10 is less than or equal to 40. I divide by 2, divide by 2. 5x plus 10 is less than or equal to 20. There's no monkey business here. I don't have to worry about it. So it's going to be 5x plus 10 is less than or equal to 20, or 5x plus 10 is greater than or equal to negative 20. So I switch it. Subtract 10, subtract 10. 5x is less than or equal to 10. Divide by 5, divide by 5. X is less than or equal to 2. Do the same thing here, and I know this is kind of running into things, so I'm just going to kind of subtract 10, subtract 10. 5x is greater than or equal to negative 30. Divide by 5, divide by 5. I'm dividing by a positive 5, so I don't have to switch the symbols. I know that there's a negative there that can be confusing. Greater than or equal to 6. So I have x is less than or equal to 2. And greater than or equal to, sorry, that should be a negative 6, and greater than or equal to negative 6. So it's less than or equal to 2, greater than or equal to negative 6. So they meet up. So I know it's going to go from negative 6 to 2, my graph does. It's including because it's closed, and so that's how you do the homework.